While you might be able to look this integral up in a table, most people don't just use a table to do this. This integral does not give us an inverse trig function or anything like that. And notice if you try to do a u substitution, your du is going to have an x times dx in it. And since we don't have an x in this integral, that method is not going to work out so well. So the only thing we can really do is rewrite that denominator by factoring. It's a difference of squares, and it factors into x plus 1 times x minus 1. In order to integrate this, we need to use partial fractions. Partial fractions says that we can split that denominator into its individual factors. Because both of those factors are linear, we can just put constants in the numerators. And if we multiply every single term by the original denominator, you'll notice that we get a whole lot of cancellation. In fact, all of the denominators cancel, which was kind of the point. On the left side of the equation, we're just left with 1. On the right side, we're left with a times x minus 1 plus b times x plus 1. While we could multiply out the right-hand side of this equation and match up coefficients with the left side of the equation, in this example, we can actually choose specific values of x to plug in. For example, if we choose x equals 1, the equation turns into this line right here, and you can see that the a term is going to zero out, leaving us with 1 equals 2 times b, or b equals 1/2. Similarly, we can choose x equals negative 1. Plugging that into the equation zeroes out the b term. We end up getting 1 equals negative 2a, or a equals negative 1/2. Now we did all of that work just so we could rewrite this integral, and to do that we're going to replace the original integrand with this piece up here with a equals negative 1/2 plugged in and b equals positive 1/2 plugged in. Rewriting these two integrals just by pulling the 1/2s out shows us that we have a couple of easy integrals to complete this problem. And while that answer is pretty good, let's make it look a little bit more like the answer you would see in a table of integrals. Here all I did was rewrite the two terms in reverse order. Then we can factor 1/2 out. Then we can use the property of logarithms that says if we're subtracting two logarithms and they have the same base, we can combine those two logarithms into one by dividing the two arguments in the logarithm. Now that looks like a pretty good answer to me, but for fun, let's do a couple more things with this. You'll remember that there's also a property of logarithms that says we can take a coefficient in front of a logarithm and put it on the power of the argument of the logarithm. In other words, we can take that 1/2 coefficient and put it on the power of what's inside this logarithm. And a 1/2 power is the same thing as the square root, so we could write this whole answer just like that. And I don't know which one of those answers you prefer. I think this one looks pretty nice. This one's pretty good too. You can go ahead and pick your favorite, but I'm going to zoom out on that thing so you can see all of the work that we did for that integral, and I'm ready to check out the next video.